Identify the goal of the question. The objective is to find the experimental conditions that will maximize the amount of H2 present in the reaction mixture at equilibrium. Analyze the balanced chemical equation. Looking at the reversible system, Li3N plus 2H2 is in equilibrium with Lin2 plus 2LiH. Note that H2 is a reactant on the left side of the chemical equation. Therefore, to maximize the amount of H2 at equilibrium, we must apply external conditions that shift the equilibrium position to the left toward the reactants. Apply Le Chatelier's principle to temperature. The standard enthalpy change of the reaction is delta H degrees equals minus 192 kilojoules per mole of reaction. A negative enthalpy change, delta H degrees less than 0, indicates that the forward reaction is exothermic, meaning it releases heat as a product. Li3N plus 2H2 is in equilibrium with Lin2 plus 2LiH plus heat according to Le Chatelier's principle. Increasing the temperature of an exothermic system adds heat, stressing the equilibrium. To relieve this stress and absorb the added energy, the reaction shifts in the endothermic direction to the left. This shift successfully produces more reactant H2. Apply Le Chatelier's principle to pressure and volume. Identify the physical phases of all chemical species in the balanced equation. Li3N, Lin2, and LiH are solids and do not contribute to gas pressure. Only H2 is in the gaseous phase. Count the moles of gas on each side of the equation. Reactants, 2 moles of gas. H2. Products, 0 moles of gas. According to Le Chatelier's principle, if we decrease the pressure of the system by increasing the volume of the reaction vessel, the system will shift in the direction that produces more moles of gas to counteract the drop in pressure. Since the reactant side has more moles of gas, 2 greater than 0, decreasing the pressure by increasing the volume shifts the equilibrium to the left, maximizing the amount of H2 at equilibrium. Combine both conditions. To shift the equilibrium to the left and maximize the amount of H2, we must increase the temperature and decrease the pressure by increasing the volume. This matches option B. The correct answer is option B, increasing the temperature and decreasing the pressure by increasing the volume.